Hey, what's up, y'all? It's your boy Chris here, running on Bitcoin. Yeah, a lot has passed since a lot has changed since the last video. Basically, I've right off the bat, I'm a network engineer for a local government, and I work on many things. What I do specialize in is Cisco Fortinet, so I have to know both Cisco Fortinet products, the way how to configure them, so on and so forth. Now, recently, the whole craze has been AI, a lot of the AI agents and stuff. And I'm going to be honest, guys, this stuff is amazing. Now, I kind of already been working with it and messing with it way early on. However, what's been new is I've been messing with local AI. So as you can see above me is Claude. Now, Claude recently came out with a Claude Code UI for it. So I was always used to using Claude Code and CLI, but now they made an actual graphical user interface for Claude Code. And that's what you see, that's what you see up there. So you see that here is it's a user interface that I'm creating where I can basically orchestrate and talk to my agents from one interface. So how it is usually you would go into the CLI and you would basically have to talk to each agent in separate terminal sessions. So you SSH into the machine and you talk to them back. Then another thing is local AI, right? What's the difference? Well, what's been happening is a lot of people are using cloud-based frontier AI models. So you have like Claude, Codex, Grok is actually coming out. So Elon's Grok is actually coming out with the CLI. You have all of these very powerful tools that are cloud-based, and you have the Chinese models, GLM, Quinn, anything, I believe, right? Now, the thing about using something like Claude is, depending on which subscription you have a $20 subscription. That's the one I'm using, right? You can be rate limited pretty quick if you're trying to do a lot of stuff at once, and you have to wait 3 hours, 4 hours, depending on what it is, for that limit to be reset so you can use it again. Now, when you bump up to it's like $100, $200 version, I don't really remember, but that window, that limit increases to be able to use more. Me, I stuck with the $20 plan because I'm not going to use it crazy like that. But what I do use Claude a lot for is the Claude Code functionality, but also being able to, have something, a little bit of that extra horsepower if I need something to troubleshoot. If I need to troubleshoot something, have agents running. So the agents that you see on the screen here to the right in the user interface, these are local agents. So how I'm running these, I bought a Nvidia DGX Spark. It's a little box, and basically, if I might be able to show you all. So Nvidia DGX Spark, and yeah, this is pretty much it. So this is the little box here. That is what I purchased. I want to say about 4 weeks ago, almost 4 weeks ago. And this thing has been amazing. It has the GB10 Grace Black Whale super chip in it. And what's interesting about GB10, or you may see GB10, you may see GX10. What's interesting about this is these models are pretty much so you have the DGX Spark, but what I notice is you have Lenovo, they make a version of this. You have Dell, they make a version of this, right? And I didn't know that. So I like the look of the DGX Spark. I like how it looks. It has like this foam texture in it. It's not even foam. I don't know what you would call it, but that's where you kind of feel the airways in the fan. Not how it all moves on. But what I can get at is you have the Lenovo. I think it's like GX10, right? Here it is. This is what it looks like. It looks very similar to the DGX Spark because it's basically the same device. It's pretty much the same device. It's just Lenovo. You have if we click here, we have the two Connect X7 links. These are great because it allows you to cluster your machines. So if we go back to the DGX Spark specs here, we see that 1 petaflops, blah blah blah, 128 gigabytes of coherent unified system memory. That's the max that this system memory can have in it. However, if you use the Connect X7 links, you can actually cluster them together. So let's say you bought another one, which I'm definitely planning on doing. You can cluster the models and basically get double that. So you get 256 gigabytes of unified memory. Now, what you can do is you can also buy a switch here. I think it's like a MarcoTick switch. So these MarcoTick switches are going up in price, but basically you can buy a switch like this, right? And this uses the 400 gigabyte QSFP connectors. These connectors, basically, you can plug a breakout connector into this one that breaks out into 4 separate QSFPs and connect them to your DGX Sparks. So now you can have 4 DGX Sparks, not just limited to 2. You can have 4, all right? And you can have another set. That's 8 DGX. And you just keep adding on. But the amazing thing is, all that RAM, will be able to help you run like local models, like bigger local models. So back to local models, right? Basically, you're going to need that speed. You're going to need that RAM and storage too. It all depends. Like you don't have to download a bunch of models, right? So storage is not really the huge problem. But the huge thing will be RAM. Now, okay, what's so important about the RAM? We go to Olama. Olama is pretty much it's one of many different providers with models. You have open parameters. You have Olama. You have Llama, which is more CLI based, but you can run GGUFs models or like custom models, and you can even use those GGUF models to retrain, fine tune, which you will use in like Unsloth, which Unsloth is a nice platform, a nice user interface where you can actually train your models to learn certain different things. That's models. That's not like agents, AI agents. No, we get to agents a little bit. So models, Quinn 3.6 is on top. That's actually pretty crazy. So these are popular, the most popular and the newest. So yeah. So let's go to something. Actually, Quinn 3.6 is actually in the cloud based. I can actually fully run this. They got a 35B, 83B. So these are all so basically I'm definitely gonna download. So what I am doing here and what I'm looking at, and I read off some numbers, right? So when you look at these models, you're going to see like 35B. These are all 35B. We go here to Med Gamma 1.5. This is Google's medical AI model. So those you'll see it says like 4B, right? And let's say you go to Nemotron Cascade 2, you have 30B. You're going to notice there's different numbers, right? You're going to have like 24B. These numbers is basically the amount of RAM you need. Let's just say, plain and simple, like Nemotron 3 Super 120. That means you need to have at least 120 gigs of RAM available for that model to load. Every time that model needs to do something or load and do something, it needs that RAM. It stays in that RAM depending on the timeout, right? Models will will boot into RAM, and then it just wait once the tasks are done. And when it's not needed, or you cancel the session, or not the session, but the running task of the model, it'll drop off, and then you get that RAM back. So that's been the crazy thing about local models, is you need that memory, right? And unified memory is what makes it faster. Now this Quinn 3.6, this is looking delivers substantial upgrades in agentic coding and thinking preservation than previous Quinn models. So, okay, we're in Llama, right? This is Llama. I use Llama to store my models. How would we actually go ahead and download this model? Now, what's cool about the DGX Spark is it comes with you can use a program here where I can go in and install it. However, just because I'm in the middle of working on this, I can actually do it from here. So how I built this platform you're looking at now is through a combination of many things. My agents, my local agents, and Claude Code, and I'm able to build that. So here I'm able to talk to my agents, voice chat if I wanted to. I'm able to talk to them through the actual chat here. I can bring certain models in and out if I wanted to. I have to just bridge it up, but I'm going to bring them all up. And, that's just a quick showing of what that is. I'm using Nemotron Cascade 2 for all of them. So, back to this. So, I want to start installing that. So, we're going to go in. I'm going to all right. So we're in the CLI. Basically, what I want to do, I want to blow this up to show you. I am actually going to install this plan. So I have Obama already running, right? How would we install a model? Okay. So I'm looking at these models. This is your context. This is how much that model can retain and hold. Okay. For, let's say, like you're asking it a bunch of different questions all in one prompt, and it go ahead and start doing stuff that is built up based on that prompt. It builds up. It's like it's the context window is the amount of context that model can hold in that specific prompt session. Like, just trying to give you. So if it will basically, let's say you prompt and say, hey, I want you to, we can do this, right? I'm just going to give you a good example. I want to make sure we all get a good example of this. So let me take that out. And I'm going to ask, Bridget, right? I'm going to ask Bridget here. Give me the latest news on cybersecurity events. Okay, I'm just going to send it off to you. So basically, what that is give me the latest news on cybersecurity events. It establishes a little context window. Say, okay, this is how much. It gives you a progress, which I should actually program that in so you can visually see it. But if you ask it longer questions, that context window will increase. And 256,000 tokens, something like that, is the context window. That's pretty large. You have something less. That's pretty much what it is. So Bridget basically is going to go out and look for like the latest cybersecurity news, the news of cybersecurity events that are going based on her program, based on the skills that I had her build for. So And also with local models, they are, depending on your build and what you have, some go fast, some go really slow, depending on the models that you use. So Nemotron Cascade 2 base has worked fairly well with both speed and just basic tasks. Once you go on to like Nemotron 3 Super, 120 billion parameters, it starts to get, it's doing more things, but it's also a little slow. Now, that's been the interesting thing when it comes to local models, is trying to get it to run good. Now, if you try to use like graphics cards and things like that, things are going to be different. It all depends on your actual machine, not relying on an actual cloud platform. You're relying on an actual machine. So while Bridget's going ahead and looking at that, we are going to go back and I want to show you all. It's that. I'm going to show you all. So I just want to make sure she's actually going to do it, because there was a bug earlier with it that I had fixed here. So we're going to go to plan, and we're going to go to the one that I want to install this one. Which one? This one right here, text and image. Let's install that. All right. So we go back. Okay. Yeah, she's hope there's not a bug. We think there's a bug. I'll just let her. I'll just let her keep going. I think there's a bug. Well, the issue I've been having is when you say another prompt to the same session, it acts weird, it crashes. So but basically, when I say paste that in there. So now it's going to actually pull that. So it's about 71 gigs, right? It's going to start installing. So what I'm doing is I'm installing the full model into the machine. So you're not using like an actual cloud platform. So while that is loading, while that is installing, yeah, I think there's something wrong with Bridget. I'll say text. See if she's actually responding. See, there we go. There we go. See the text. There it is. Hi there. I'm Bridget. Blah 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 blah. Coordinate research. Search. Blah blah blah. So you're basically telling everything. So I'm not sure why she took so long, but next thing. So let's see what she said. Hi there, I'm Bridget, your AI agent security cyber analyst, and I've just refreshed the news speech. The same prompt, blah, blah, blah. For their research. Okay, so this is probably my last prompt. It took a minute, right? It took a minute because she's going all over the place to find these news. DPR link, blah, blah, blah. For that blog. I have, this is interesting. 2026. Sure, efficient Anthropic AI capability project last week being invested. Also programmed so I can blow it up so you get it. And then she gives you a lot of details. And I have where she actually saves these reports as text files. And then I also have where she cleans it up. So like after 2 weeks, after a week, she cleans things up in her session. So Tina is my email, so I can actually tell her to send an email to somebody. I can say, hello, Gidget, how are you doing? I say, hello, Kitty. Let's see what he says. Hello, this is Gidget. Everybody's malware. Yeah, I'm doing great. Thanks for asking. How can I help you today? Are we diving into for them best practice guides, reports, and firewall clearing? Or is there anything security tasks in mind? Let me know. I can say, I'll drop some malware into your malware analysis folder in the future. Just be prepared. So basically, what I'm doing for him is he will be more like dissecting AI. See how quick that? You see how quick he is? I don't know why he says kitty. Sorry, I gotta fix that. God, kitty. Well, I don't know that you'll be dropping malware samples to now. It's totally later. So I'll keep that. I'll keep the sandbox YARL rules and reporting pipeline primary. So he has like YARL rules and stuff in it too. So let me see. Also, my name is not Kitty. It's actually Christopher, but I accidentally said Kitty. So you won't get confused. Because so the back end, how this is working is it got it, Christopher. Thanks for correction. I'll make sure it's used Christopher whenever I talk to him. I'm all set up the sandbox. So basically, the back end to this is actually Hermes. So here's another thing about local settings. Claude uses the Claude Anthropic platform. Then you have, when you're going into more local infrastructure. Let's say you buy a Mac Mini or something like that. You can use Claude in certain, platforms. You used to be able to use it in OpenClaw, but then Claude pretty much stopped that. But basically, OpenClaw is where you can have your models run. There's a gateway that exists. That gateway connects your agents to the rest of everything else. The gateway, it contains configuration files. It contains everything you need. Hermes is similar to OpenClaw, but what I've experienced is like 10 times better. 10 times better. And why I say that is there's always major bugs in OpenClaw to me. It performed well, right? When it works. They did make a lot of updates to OpenClaw since I've used it. But Hermes is like, it's solid. It's real solid compared to OpenClaw. So that is what I use in the back end, but you don't see that here. But if I were to show you all what Hermes looks like, I can spin up. See, this is at 11. Yeah, just at 11 gigabytes. So it's gonna take a minute. It is. It's gonna take a minute for this queen. But I'm interested to see how this will work in my network engineering, right? My network engineering model. So Isaac, give me a configuration on how to configure a VLAN on a Cisco switch and assign that VLAN to a port on the Cisco switch. All right. Configure fix that VLAN on the Cisco switches and assign. Fix that. assign that VLAN to a port on the Cisco switch. I do have some noise in the background too, so that's another reason why I'm having issues. All right, so all that is, what he's going to do is, what I've established for him is I create a folder that contains PDFs and certain links that Isaac can look at, analyze. If it's a link, he goes to that link, and then he reads it, and then he stores it in his own memory. That's another thing about Hermes. They actually have they have memory. I'll call it in the beginning that they start adding that in, but basically, an agent takes what you give it, and then you tell them, make sure you remember this, right? Make sure you remember this, and then it stores everything in memory, so it remembers what it needs to do in the future. So, what I did with Isaac is I threw Fortinet documentation at it, everything from the FortiOS. So that means like administration, FortiGate administrations. The entire CCNA PDF book. So it has all you want and two in it. So he knows everything in the CCNA. The Forti Switch, Forti EDR, a whole bunch of things. And I had to tell him this Cisco stuff, this is what you do. So you can actually see he's putting out giving you the configurations. All right. So he will actually say Cisco switch, VLAN creation, port assignment, plain text, no markdown. And he tells you the reference where he got it from. The official CCNA guide. Volume 2 PDF shows blah blah blah. Switch port access, create the VLAN global configuration, enable configure terminal. VLAN 30, you give it the name, finance, boom, exit. And it even tells you choose the VLAN number you need. Give the VLAN description, the descriptive name. The PDF notes that a VLAN interface appears as VLAN 30 once the VLAN is assigned. Well, it's defined, right? So verify the VLAN exists. Show VLAN 3. The VLAN should be listed with its name and the ports currently using it. Assign a physical port. So he's giving interface, gigabit, Ethernet, 1. And then you have the description, finance port 1, switch port mode access, switch port access unit 30, spanning tree port fast. So it's going to be a edge device, an end user device, right? No shut, and then exit. That's a config right there. And then he gives you key points. Forces the port to act as an access port rather than to trunk. Behind is the VLAN to the port. So this is all coming from the documentation I fed it. Why I did it this way is because in AI, certain models, well, I won't say certain, all models can what we call hallucinate, which it may not know the answer to something. So what it does is it invents an answer for it. It could easily just say, I don't know, but most of the time it'll try to invent something if it doesn't know. Does it happen often? It could, depending on how, depending on the data it gets. If you're depending on just it going out to the internet, you can run the risk of higher chance of your model hallucinating. So it's always good to try to give your agents in mind, right? Try to give your AI, I'd say that. Try to give your AI a good source of truth. So my source of truth for this was Cisco CCNA. He had others packed in his folder if he needed to, but this was definitely the Cisco CCNA. Let me just get up one moment and let me put this on. turn up the AC real quick. Sorry about that, guys. Okay, so yeah, summary, quick copy and paste. This gives you the full on configuration. If I'm already in global configuration, all I gotta do is just copy this. That's basically so that so this is great to have, right? Uh, it's great to know the technology first too before you try to automate something. This is the next step, I believe, in network automation. Because what I can also have Isaac do, which I haven't, is I can have him SSH into routers and switches. I can have him use NetRepo and then ask him to do this stuff, and then he goes ahead and he go and configure the thing, configure the router, configure the switch. As an agent, he can do that. The model he's running is Nemotron Cascade 2, latest. That's his brain. And the agent has all the skills and everything to back it up to do what he needs to do. This is the next step. People have opinions on network engineers now. And before AI and agentic AI started to get real big, I started network engineering it was like right after the SD-WAN craze, and then we started going into more of like network automation. But the network automation back then was more of like, okay, you're network engineers, now you have to learn Python, now you have to learn YAML, now you have to learn all of this stuff on top of network engineering and all the protocols and all the different technologies behind that. I feel like as network engineers, we shouldn't have to spend a lot of our time learning Python, learning how to fully code. Because we're network engineers, we are busy learning other things. So I feel like AI, agentic NetOps, I guess you could call it, has allowed network engineers to basically focus back on what we know best, which is networking. Now, would you trust this in a production environment? I would say best move, get local AI in the organization. Why I say that? Because it's safer. It's local. It's running on the actual machine. It's not going out to servers and then coming back with that information. You're using it completely local. Second, instead of you having your agents grab information from the firewall, I would say have information from the firewall in almost like in a static sense. So, for example, having one of your local agents connect through the Aavik API. Then from there, and Aavik is a network monitoring tool. So whether you have Aavik or a PRTG, whatever, right? Have your local AI agent look at that information and reference that information instead of going directly to a firewall or the device to see what is there. The reason I say that is because Aavik, Aavik doesn't actually change the network, but it sees changes on the network. So it makes better sense to have your agent go there to find all the information it needs instead of going to the firewall. What it means, right? But also, giving your agent certain rights, create an account, create a separate Aavik account for your AI agent. Okay? Have it just read access only. That way, you don't run into the risk of it. Who knows what it might do? It may try to write something to it. Will it? Probably not, because it didn't prompt it to do it. But who knows? Anything can happen. But that's one way to do it. So, and then when it needs to actually make configurations, have it stage that configuration first, like what I'm doing right now. and it gives me the config. And then I look over it, and then I look at it and I say, okay, cool, this looks good. Now go push it to core switch one. Right. Boom. It uses NetDeco, SSH into core switch one. It runs these exact configs. If it running into any issues, you can actually tell it, I want you to check, before you disconnect from the switch. Or I want you to check your configuration and make sure everything is good before you disconnect. You can ask it that, or you can give it a config file, an agentic. In local AI we have like agents markdown files. We have a lot of markdown files, and basically these are like different instructions, different files where you can put instructions in for your agents and make a file. So you can actually have that as like a lack of a better term, but a playbook, right, for your agents, and add that to like your agents.md markdown file. Then it will always know, all right, this is what I need to do before I do anything else. Double check. So you can do that. So let's see how this is looking. Okay, so it's we are at 32 gigs, so it's going to be a minute. But the reason why I got attracted by Quinn 3.6, because I already heard good things about it. But then when I heard, when I saw that it's not just cloud based, you can actually use this locally. So, and it's 35 billion parameters. That's not bad at all. I mean, for what I thought, I have 128 gigs of RAM, unified memory, but I want to make sure, it's a good size. But looking at this, right, agentic coding, the model now handles front end workflows and processor level reasoning with greater fluency and precision. And it's scored pretty high compared to dense models. So MOE is, so this is new to me. I'm trying to learn this stuff, but it's like something of experts. Basically, a model the best way I can explain it when I was reading about it is, let's see if I can actually see MOE. Mixture of experts. So if I can sum this up perfectly, a mixture of expert models is basically one large AI model that is compartmentalized into different sub-models that do different tasks. They're more efficient to run compared to dense models. Well, that's what makes them more efficient. Is that way of dividing a large model into smaller models with specific tasks, but they're all working as the same model. I'm trying to explain this as easy as I can. I'm also talking slow too, because I'm also learning this myself. So that's another reason why I would also want to test this out. And I might run this on my network engineering Isaac. I want to run this on that agent to see how he works. But back to Llama. Llama basically have all of your different models you can choose from and have your agents run these different models. Another good model is GLM 5.1. However, just being cautious here. It's only cloud-based, and this is a Chinese model, so you do want to also watch for if that is good. I kind of don't like using cloud models, especially that are made by the Chinese. But I will use them for like quick tasks if I don't have Claude Code, or if let's say I stop using Claude Code. I will use GLM5 to do certain things, but never put sensitive information in it. It's okay to put sensitive information in local models, but you want to make sure you're also doing that securely. So, for example, don't try to store plain text in the model, an internal model, because let's say one day your machine gets hacked and someone has access to the model on the network. But now you have sensitive information that the model can't give out. Or he can just SSH into the machine and he have access that way. But if you have, like, for example, here's a good threat, a good threat vector is this user interface that I have, right? You want to make sure that let's say you work in a company, you build something like this. You want to make sure that you have this setup guarded and protected in a way that only certain people, certain machines can access this website. So you want to make sure in your firewall that you're actually blocking this website only for certain people can actually be allowed to get into it and see it. Because if I was a hacker and I gained access to your local network and this had no rules on it and I accessed this website, there's no sign in. I could add a sign in and then boom, now I got protected and that's more protection. But in this case, I don't have a sign in. So I will now be able to access these agents, grab information from them. What's interesting about this is that you can also tell your agents never give out personal information. So if you had an email agent, right, and it's holding a phone number, why would it hold a phone number? Okay, let's say your agent gets an email from a client and it doesn't know how to answer that email. You can escalate it to someone and it could maybe send a text to someone's phone. Or if it's holding an email of someone, or the email of the CEO, right? Or someone in the team, right? It needs to escalate the email it got from its clients to someone in management. It's holding that email somewhere in its storage. The best thing you can do is say, look, do not give this information out without further permission from Joe Schmo. Whatever. And then you can have it go to a telegram, like, hey, Joe Schmo, someone's requesting your email address and phone number. Should I do it? No. And they don't. So, and it really can do that. Like, it's not just making something up like that. An agent can really do what I'm explaining. Okay, so I forgot what you call that. I think it's like redlining or something like that. That's the term. It's redline. Also, prompt injections or goal hijacking, which your emails go back to the email agent. You have what's called a cron job. A cron job is basically a job that allows the agent to run a certain task every so many times, or every 3 hours, 2 hours, whatever, however you want to say. In this scenario, let's say your email agent wants to, you want your email agent to look at the latest emails that it received every 2 hours. I'm just making stuff up, right? Let's say every 3 minutes. It's looking through emails. And then it sees one email from somebody that matches all the criteria. But then mixed in that email is it looks like a prompt. There's a good chance your agent could read that in that email and think it's actually a prompt for them. That's prompt, and then it injects that prompt into that agent. So that's prompt injection. It can be something that looks like a prompt that's trying to extract information from the agent. So that redlining helps in a sense with that. But there are other security ways you can do to try to prevent that from happening. So that's that. One other thing you can do is, instead of storing that information in the agent's file, you could have it look into a different folder on the actual machine. Looking at that way. Now, again, you're still dealing with, they need to go back to see something. It's a great chance that someone's going to be trying to something on those. It could be that someone's be trying to extract information from the agent. So that's prompt injection. Yeah, I can't wait to use this. It's cool. It's cool model. I want to see how good it is in code. I want to see how good it is, working with the Cisco stuff. Those is killing. I thought about doing this live, but I was like, you know what? It's kind of late. I'll just make the video. So it feels like a live, but it's actually not. But yeah. Who did I cover? I would cover Tina, but it's emails and stuff. I don't want to give anybody my emails. So yeah, this is bunny glass, right? Nah, if I go back, but oh yeah, I was gonna show you all what Hermes is. So let's go back. The wrong password. Right. Here. Oh, you know what? Because it's not clear, it's not. It's a different way on set. It's not like, see, if I was in like the actual CLI, like the legit CLI, it'll that clear command board. But then let's say I type Hermes. Oh, so this is what Hermes looks like, and Hermes agent, and this is how you would code. This is how you would work with Hermes and your agents if you didn't have like that user interface that you see the model. So the default Hermes model running is GPT OSS 120B. You know what I'm thinking about doing? I'm thinking about using the Quinn. The local Quinn 3.6, and see how well Hermes works with that. That's just crazy. That's just crazy. That'd be interesting to see how that went. This was updated yesterday. 30,000 downloads already, and it has vision on it too. So this is Hermes. Now, what's cool about Hermes is you can create what's called profiles. So maybe like Hermes create profile flag in the agent's name. So profiles is basically, so OpenClaw, how you would create agents in OpenClaw, you would have to go into the folder, build that folder out in the agents folder, whatnot. They have the workspace, and then each agent will have their own workspace, things like that. So when you download these platforms, you're given by default like a main agent, or like a main agent that can manage everything, right? Or you can give it to manage certain things, and then you create other agents on top of it. So how OpenClaw did it was more. It was more a lot more back end work. Now with Hermes, it's more easier. So you can create what I call profiles. A profile is basically an agent's own workspace. So there's a command on how to on how to create an agent. So how to create a separate AI agent in Hermes profile create, and then a new profile name, and then it will build everything else out in that directory. Now, being that I have Tina, Isaac, Gidget, Bridget, those are 4 different profiles. Those 4 different profiles each represent an agent, and within those agent directories are its files, everything about the agent, everything about me, how the agent should talk to me, the skills, everything. So I have the Isaac. I just type Isaac, and this is his setup. I'm going to actually change this and put his actual name, and I can do that. I can basically go to Hermes agent and be like, hey, change the ASCII, change Isaac's ASCII to Isaac-agent. It'll find it, boom, boom, it'll see the ASCII, what it needs to do. Boom, next time boot it up, boom, he said, it has his name there. That's what I did with what is it? Type Bridget. Boom. Okay, Bridget, agent. She's the routine cyber person, defend and protect, right? So I had all this customized. Now in Hermes, this is called a scheme, right? So how you see the blue shield, that's her emoji. This image is different. Her ASCII actually says her name. This is what it's called a scheme. And in Hermes, you have scheme, right? And I have different names for it. Scheme. And these are the different skins, available skins. Plasma Hermes, Aries, blah, I have the Bridget skin. That's there. Bridget agent custom scheme with shield banner. That was something I made. So that's hers. Tina, she's the email and help desk person. So their Tina agent has like a little mailbox, a little mail envelope. You got mail. Her emoji is a coffee emoji, right? Again, these are skins. This is something you can most likely probably do on OpenClaw, but it's a little bit more like research on how to do it. But I will say, the best thing you can do if you're working with anything, if you're trying to get into this AI stuff, definitely utilize Claude. Definitely utilize Gemini. Utilize all of these different AI models. Like, definitely use all the tools at your disposal. There's absolutely there's no excuses for not being able to do anything at this point. At this point, it's like you can do everything. I'm gonna fix this daytime. Daytime looks pretty cool, but I'm gonna fix that actually. And actually, I need to move this over. There we go. Oh, it looks better. It looks 10 times better. Move that right there. I'll make sure I remember that next time. But it looks. Yeah, you can probably see everything, but this SSH. Do I need this Hermes status? Blah blah. No, I guess it's some stuff I can just keep this feature, but it's not really useful. Settings. This is where you can. So, how I'm able to see everything. So, how I'm able to see the agents. Now, another thing in Hermes, which I'm not sure what OpenClaw did, but in Hermes, each agent have a network port. That can be open to the rest of the LAN, but don't quite have to. It can be open just to the machine itself. This website is running off that machine now, but I'm able to see the rest of the agents through port 9191. But these agents can be on port 8560, 8562, 8563, 85. It could be on any of those ports. Those ports represent where the agent is listening on. What I've had the AI do is actually in the settings here, scan those ports so from port 8630 through 8700, scan those ports within that range, see if there's an AI agent listening, and if there is, populate this field. And that's exactly what it did. Why I did it this way is because this makes this program way more modular or more transparent. It's not just matched to my models. If I ever uploaded this to GitHub, make sure everything was clean before anything else, nothing is hard coded. I can upload this to GitHub. Someone else can clone this project, and they can basically see their own agents populating the same exact thing and use the same features. It's just on their own setup. Again, though, you have to be using Hermes, right? And you want to make sure your agents are actually listening on a port. Because what will happen if they're not listening on a port, it will show offline. Or they just won't see the agent at all. So that's one other thing. So, this Quinn is almost done because I wanted to show you how to change an agent's model. Changing an agent's model, it's like you're changing the brain of the model. I'm trying to make it as simple as possible. You're changing the brain of the model. So, for example, all of my agents are using the Nemotron Cascade 2 latest model. But they all don't have to be using that model, which I'm going to demonstrate. I can have Isaac, instead of using the Nemotron Cascade 2, he can use the Quinn 3.6. Okay, and that'll be his model. Will it run faster than Nemotron? To be honest, probably, because Quinn is actually pretty fast. We'll have to see, right? And this is all I've done. Like, this is all I've been doing with this AI stuff. It's just basically just experimenting with a whole lot of stuff, and I've been doing this for like the past 4 weeks. Haven't had any sleep. I've literally been trying to learn as much as I can with like all of this stuff, and it's absolutely mind-boggling, right? Mind-boggling in a good sense. So in the future, I will be getting one of these because to be honest, I'm not sure how long they're gonna stay in stock. Like this, it's already saying backorder reserve now. Like the reason why is because of clustering the GX10 computers. Like this is exactly why they're on backorder. But yeah, you have Asus. Asus got their own thing. It's the same. If you look at the back, the same exact model, like the same exact computer. Now you can see it's how they were clustered, right? You put two together. Now what's interesting is that the Mac, go here. If you go to apple.com, the Mac Mini and the Mac Studio are two computers that are also very popular in this space. Mac Mini kind of blew up in social media, but the more you deep dive into AI and how local models actually work, you're like, why are people getting the Mac Minis? They're not as powerful as like the Mac Studio. They have way more RAM, right? So people were getting Mac Minis because of like, I say because of height. Yeah, you have the unified memory, but the more the more I dived into this, I'm like, why were people getting Mac Minis? If anything, they should have been getting the Mac Studios. And the reason I say that is because if we go to Mac and we just say Mac Mini, and then we go to buy, we're given the stats, right? Um, the most important thing we want to look at is the M4 Pro chip. Okay, the cores that it has, everything like that. We click this, we got 12 core CPU, 16 core GPU. You know, you want to go with the top of the top. Okay, so we out the bat we're going like 20 GPU. Right? Mac Mini, this is all the memory you can get, which is a 64 gigabyte. So this goes back to building parameters for your AI models. With this Mac Mini, you can't run a 120B model. You can't run three 35B models. Okay, you can't run two 35 billion parameters models. Now you probably could if it was well trained and whatnot, and you know maybe there are models out there that are like so compressed, right, that it works like the 35B. But we're just talking basics here, right? You can't do that with just one Mac Mini. Now you can buy two and cluster them, okay, and now you have a bigger, you have a bigger model. You have a 128 gigabyte model, but now you're matched what my DGX has right off the bat. Okay, so and then storage, 4 terabytes will do the trick. 2 terabytes will do the trick. You know, 10 gigabit Ethernet, of course. And then you go all that. So, and then you're gonna eventually end up with the max you can get. So let's just say I was continue shopping. Okay, I do 64 gigs because why not? 2 terabytes. Now, if I were to let's say I just match it with the specs that I have with my DGX. No, I don't need all that extra crap. No. Okay, buy it, $34.99. Okay, that's less than the DGX, but you remember you're not getting that extra 64 gigabytes of RAM. Okay, you're just getting 64 gigabytes, and you're probably getting like 63 gigabytes of RAM. So, that's the Mac Mini. Okay, but then I was like, and you look at it, currently unavailable because people. Because people have been buying it already, and it's actually pretty crazy. I'm going to take a snapshot of this. People been buying these like crazy. Just took a snapshot of that because I'm gonna go to my X and post this real quick. It's unavailable. Currently unavailable. You won't see what I'm typing, but it's crazy. Okay. So out of stock of the Mac Minis. What about the Mac Studios? If you hear noise, that's my AC going on and off. So sorry for that noise, but it can get warm here. So what about the Mac Studios? You go to Mac Studios. Buy. Right off the bat, you notice some difference. They got the M3 Ultra chip. We're on like the M5 chips with the Mac Pros. But they haven't updated their chips for like the Mac Studios and the Mac Minis. The Mac Mini is on the M4, but the Mac Studios on the M3. But you have more power, right? I can max this out and get the 32 core CPU, 80 core GPU. And then on top of that, I can go 256 right off the bat. So right off the bat, I just surpassed my DGX Spark. I just surpassed that. These are like two DGX Sparks, right, on this machine. We already had the unified memory. just because it's the Apple M series with everything already built, a system and chip and all of those craziness, right? And then let's say I do 4 terabytes, just matching with the same, terabytes that I have. And then no thanks. But you're paying about $9,000 count taxes and whatever else is in there. Now, if I would have, let's say I went down to 2 terabytes, about $8,000. But you're getting a better device than a Mac Mini. You're paying like over half, a little bit more than half to get this, but you're starting out with that 256 right off the back. Okay. So you can run like 2 120B, models easily if you wanted to. But you have space, more memory, and more rent. You have more memory for all those other smaller models if you wanted to. But as we can see, just like the Mac Minis, unavailable. These are unavailable too. Yeah. Mac Studio. Unavailable. Okay. So yeah. So you can't find them there. You can't find them on the Apple. The Apple's like they're just out of stock. Okay. What people are not looking at are like buying DGX Sparks. Just buy DGX Sparks or any of the other PCs that you can find out there. People are also now using like GPUs, like graphics cards, very very good graphics cards, and they're in like actually like your traditional computer or your gaming PC setup. Um, you know, so yeah, so Quinn has successfully installed the Quinn 3.6. So how will we check to know that it's actually there? We do a llama list. We can see all the different models. Now you see I got quite a few models here. I have the Quinn 3.6, which we just downloaded. That was 71 gigs. We have Minimax M2.7. It's the cloud model. We have the Med Gamma 1.5 latest. That was just 3 gigs. Gamma 4, the 26B. We got Neutron Cascade 2, GPT OSS 120B, Gamma 431B. That's a dense model. So dense model is different from a MOE, right? When we talk about MOEs, mixture of experts. A dense model is more of like it doesn't have that compartmentalization. It's one big thing. It's one big thing. There's no subnetting. There's no subnetting the model. This is all one thing. You got Nemotron 3 Super. I believe this is an emoji model. I think this is. But so yeah, so we got Quinn. We got this Quinn model. How will we get it to run in our Isaac? If we type, let's see, how can I do this? Isaac, I remember setup. Okay, so we're gonna set this up and say no, we don't need to import OpenClaw, and we want to go down to. Let me blow this up so we can see all of it. The choice we want is here, Olama, because this is what I'm using. So we do 26. Here it is. So it fetched the models from my Olama setup, and this is what I have. Quinn. So we're gonna do that. Set up messenger now. Yes. Let's say yes. No, we don't want to reconfigure it. What I want to do is actually in the future I want to try out Discord. Cause that's pretty cool to I have all my agents in like group chat in Telegram. It's pretty crazy. So like say something in there and they all like talking to each other. And Discord is pretty much like you can do the same thing in that too. I want to say no. Restart the gateway to pick up changes. Yes. Now gateway. Remember, each agent has their own gateway. OpenClaw was not like that. Last time I used it, it was not like that. It was more like when you start the gateway, you're starting everybody. This I'm only restarting Isaac's gateway. The other agents will still be up. So yes, we're gonna boom and then launch it. All right. So we're in Isaac, and as you can see, the model now says Queen. I don't know how this is gonna run on my machine. So my application should pick up. You see his model also dynamically changed in the user interface. So he should pick up. It should pick up. I can't remember the timing, but there's a certain timing when he finally picks up. If not, I would have to. There it is. Boom. Okay. So instead of going into the CLI and doing this, why not do it through? Why not do it through my application? I mean, you know what I'm saying? So we're gonna close all these applications. We don't need them here. Let's turn the voice. Okay. Write a Cisco CLI script that creates a port configuration for security. I couldn't think of nothing, right? So write a script, CLI, that creates a port configuration for security. I don't fucking know. I didn't know. So let's see if he actually let's see if he creates something. I don't know how slow this model was, fast this model was, but yeah. So that is that's basically what I have here. I mean, I showed you pretty much everything on this. There's certain things I need to fix, such as what I want to do is I want to show in here. I want to show when the model is actually doing what it needs to do. So in the CLI, you can actually see it, like not think, but sort of know, okay, what tasks and steps is it doing, things like that. Um, you know, I wanted to take a look into these agents to see where they don't have descriptions. Gidget and Tina doesn't. I thought they did, but for some reason the application didn't. Yeah, pick them out. So I would look at that. Yeah, let me. So it's running, pretty slow. Running pretty slow. Here is the script. Let's see what he's going to give me. This is the first time, I think this is like the first time I actually used the point model. See if it's going to give me anything. Now, while that is running, I might be able to show you all. I might be able to show you all the let's see. If I go to here, it is the script. It's been written to. Oh, so it actually read. Okay, so what's interesting about this is it created a script. Okay, so it created like the script has been written to home, Data Bunny LLC, Hermes, profiles, Isaac Workspace, Cisco, port security script. So it's in that directory. Let's see if we go there. All right. Let's see if I can see if I might be able to show you all that. We create a new view. And we're gonna do window capture. Window capture. We're gonna call this a new one. I'm gonna say miscellaneous. Right. And File Explorer. There it is. Alright, oh, that's pretty cool. Wait, could you see it? Oh. Oh no. I don't know what that was about. Okay, so if we go to actually this is not where I need to go. That's not where I need to go. I need to go to I need to go here. Mobile extern. So mobile extern, if no one knows about this, you know what? I'm gonna rename this to I got mobile extern open, but it's not seen. All right, I'm gonna create a new view. Just give it a moment here. Back home display window capture. New one, I'm gonna say mobile external. Mobile external. There we go. Mobile external is really dope. Basically, it's like an FTP slash SSH slash console slash everything. Click it. Boom. I'm already able to set the password terminal. But it gives me access to the entire file system of my DGX. Okay. So oh, you can actually see it loaded. You can see it loaded in there, the RAM usage. Because I believe there are other how I can check if there's other models running. If we let me disappear that for a second. If we go to we go to Open Web UI. Open Web UI is basically a it's a place where you can chat to your models. Okay, so no, it's there. So it's like 120 because I believe it's because of this. Now A3B BF16, don't ask me about it because I don't know yet. I don't know yet. I have to figure out and do more studying on that. Since it unloads in 2 minutes, so what that is the time once it unloads, that RAM is going to be reallocated. It's going to be available again. So, I got to research on that. That's new to me. The A3B BF16. Now, that's how I view my models to see what is actually running. You can probably run it in, so let me bring mobile external back up. You could probably say like Nvidia SMI. It tells you like, okay, Olama, but it doesn't, I'm pretty sure this is probably the Quinn model. And then you have 26, whatever that is, but this is what's running. So let me clear that out. So our AI told us that I want to see how can our AI our engineer, our network engineer, right, told us that we can find that file in his workspace folder, right, and the Cisco port security script. And I'll save this as a skill so you can reuse it going forward. Blah blah blah. Profile workspace. Blah blah blah. Structure of the script. Section 1 creates VLAN 100. Blah 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 blah. Section 2 provides a copy and paste. Blah, it tells you everything, right? Memory. Blah blah blah. Clear interface. Blah blah. To use it, connect to the switch CLI. Paste the sections in order. Adjust the user interface names, VLAN number, and description lines to match your environment. All right. Remember, this is a different model than the Nemotron, which we used earlier in this session. So let's go ahead and see. Let's see. So we're going to show you all back here again, and we're going to go to his folder. So there is the Hermes, and then there is the profiles, Isaac, workspace, and Cisco, and we're looking for port security script. I think this is it. What I like about Mobile Xterm is the fact that let me move this over here. What I like about Mobile Xterm is the fact that when you double click a file, a text file, it'll actually bring it up. Now you're not going to see it because I don't have this as a view. So I'm going to have to bring it up for you guys in the CLI. So just give me one moment here. We're going to do Hermes profiles, Isaac workspace, and we're going to go there. I'm going to do Cisco, and we're going to look for port security. So I'm going to see nano port. All right, that way you all can actually see it this way, because I don't have that as a view. When I double clicked it, it opened a separate window where I can actually make edits that way. I can also open it in Visual Studio Code if I wanted to. But this is the the author, Isaac. So yeah, it took a minute, right? But it was creating this file. So let's go through it. It says description: creates a secure access port configuration, VLAN assignment, and port security. Okay, right. Section global configuration. It knows global configuration. Remember remember the process. I asked it the prompt. It goes to its source of truth. It looks through the Cisco CCNA documentation, the whole entire PDF. And then it goes and creates this file for me. Enable, configure terminal, create the access VLAN. Okay, VLAN 100, name, users, and then exit. Create a descriptive banner, optional banner. Access control ports, authorized personnel only. Okay. Configure the maximum number of MAC addresses allowed on each. Secure port to 2. Default device plus optional guest, blah, blah, blah. Switch port security, maximum 2. So you're activating the switch port. Define the default violation mode as restrict, logs, and drops offending frames, but keeps the port up. Override per port below if shutdown is preferred. Switch port security violation restrict. So if there's any MAC addresses beyond 2, it will restrict that device from actually, talking to the network. It won't turn down the port, and it just drop packets for that third MAC address. Okay. And then we got section 2, per interface port security block. Copy and paste this block below for every interface that needs protection. Change the interface name, VLAN description as appropriate. So, this is interface gigabit 01, right? Description: secure port lobby desk. Force the port to static access mode. Must be accessed for port security function. Switch port mode access. We got switch port access VLAN 100. He's telling you, like, he's actually like telling you why this is what's so dope about it. I mean, like, I'm not even really that worried about the speed, to be honest. It's the fact that it can do this. Like, it's the fact that it can, and then we got like enable port security on the interface. You know, switch port security. Remember, we're in the port now. We're in the actual port configurations, and then it says limit to 2 secure max. Switch port security maximum 2. So we went up there. We went up there, and we was like, that was I want to say that was like global. This was like global. Okay. And then you go down here, and then you do it down here too as well. Violation action. Shutdown equals block the port. Error disabled. Use restrict for logging. So switch port security violation shutdown. So we're gonna shut down this port. So basically, the global has this strict, but if you want to get, we can get more strict by setting something like this to the individual port alone. This is, I'm going to be honest. Oh, look, you can see the RAM usage at the bottom. See, it went back down because the model timed that after 2 minutes, which we saw in the web UI. So, see how cool that is. So, yeah, this is. I'm not sure how Nemotron would have did this, but this Quinn 3.6, I'm liking it. I'm liking it a lot. I might keep this model for my network engineering agent because this file looks clean, and then I can even tell them like, hey, leave out all the comments, just create the configuration, the CLI configuration. I could do that, and I could have him go into the file and rewrite it, or I can have him create a new one. But this is even better. Let's say you're a teacher, right? Let's say you're like a network professor, and you have students, and you're trying to come up with assignments like labs for your students. This is a freaking perfect lab. You can even tell them, hey, I want you to create network labs for my students with, oh my God, this is crazy. This is crazy. So then we got like, okay, optional, set aging so that stale max are removed after 30 minutes of inactivity. Switch port security aging time, 30 minutes. Switch port security aging type inactivity. Port fast, so spanning tree does not delay the link at who has port fast. Enable DHCP snooping binding to prevent rogue DHCP servers from hijacking the map. It does all of this, man. No shutdown to bring the port up. This is optional. So he's saying this is optional. All right. Repeat the interface block above for additional ports. For example, for a second port. And then he tells me how to do a second. And he doesn't have the comments in this time. This is crazy. He doesn't have the comments in. So you get secure port reception. Right? Switch port mode access. Switch port access. Switch port security. Switch port security. Switch port security. MAC address sticky. Maximum to violation shutdown. Agent time. Agent type inactivity. Boom. Section 3, recovery and verification commands. Use these after applying the script. They are not part of the running the fed. They are verification option. Operational commands. Save the fed. Verify port security status. Show port security interface. Blah. Show this is amazing. In configuration. This is crazy. Now, what I'm probably going to do is actually create him a separate folder and go into this file and say, hey, look, any scripts you create, drop it in the scripts directory. That's what I'm going to do. Instead of just being out in the open in the Cisco documentation. Now, yes, you can go back to this file and use this as documentation, which is fine. You know, it's less clean, but he can do that. So it's not like a huge deal because he can always reference this. So what I'll do is this. For any future scripts that you create, add that script to a new directory called scripts in your workspace. Create that directory. All right. So, oh shoot, stop it. I mess it up. I want you to create a new directory in your workspace called scripts. In the future, any scripts that you create, I want you to add those scripts to that directory. I want you to create a new directory in your workspace called scripts. Okay. All scripts. Sentence here. In the future, any script that you create, I want you to add those scripts to that directory, to that, I'll say to that script directory. Be a little bit more specific. And I'm going to hit C. So I'm basically giving an instruction. Basically, so what you will not see is, and you can see it jumped to 86. See that? So the model is pretty hefty. Like it says 35B, but it's actually more than I believe because of that extra stuff in here, which I got to research on. But that's fine. That's fine with me. But basically, it's going to do that. And what you do not see in this user interface, but oh shoot, I wasn't even showing you all what I did. Take my Western. This way. So what you will not see in this user interface, you will not see it's actually thinking and it's saving things to memory. It'll actually say that, but you don't see that here. I want to add that in. I want to add that in here just because this, you know, is actually doing something, right? It's not just a blank, you know, blinking mouse, you know, clicker thing. So I want to try to add that to it as well. Is it necessary? No. It's definitely worth it. So this is amazing, man. So while it's doing that, the script. This is a really good script. I'm going to close it. I might actually leave this up because I want to show you all the directory that it creates. I had it create it in the workspace folder. Here it is. Oh, shoot. Let me show you. Okay, so he's doing it. Done. The directory is now at workspace. It's called scripts. Here it is. Here it is. And it says, through the call, I moved the script there. I'll save this preference so I don't forget it going forward. It even moved it. Perfect, Christopher. I've got the scripts directory created, the saved, and the port security script moved in there. From now on, any script I create will automatically go to this. Let's verify. Let's see. Let's see if he did it, right? Let's see. Okay, so we're back here, and we see the scripts directory. All right. Let's go to the system. Do we see it? The port security? We see it. It's it. Yeah, he moved it. He moved it. That's that at the end. So we go back. We go to scripts. Oh, he did it. He did it. Port security. He did it. I didn't have to do it. this model is amazing. So I know, I'm still playing around with this stuff, but this is just everything is still here in the file. So that's crazy. That's crazy. Okay, so we're out here. Let's see a line. Yeah, it disappears because I just refreshed everything. Scripts. Scripts. There it is. So this is why I've been like, I work tomorrow, and I haven't gotten any sleep because I'm doing this thing. But this is stuff like this, right? I'm planning on running a business too, a networking small business. Stuff like this, it's definitely going to help me out. I'm telling everyone on my X. About the YouTube video. Okay. So I want to try to end it here. I want to try to end the video here. But I just want to just show you all what you can do with a it's a lot of stuff you can do. And it's all about just experimenting and playing with many different models. I'm liking it playing 3.6, 35B, 83B, BF16. This model went through some training and fine tuning. Yeah. I mean, I don't know what else to say. I would like to. So the model's going to time out in about maybe like a minute or two. But this is local AI. This is local AI. So I'm not going to like server focus or anything like that. This is all running on DGX Spark. Okay? It's all running on this guy here. Nvidia Spark is basically, it runs an Nvidia version of Ubuntu, but it's just Ubuntu. That's with some extra stuff. It has this thing called Nvidia's Sync. You could basically, I lost my train of thought. You could basically click on SSH into I like my mobile external because I can go through the file system and do all of that. So yeah. So it's been a long video, but I just wanted to show you all the stuff that I'm doing, what I've been doing, and what I've been playing around and testing out. It's absolutely crazy, man. It's absolutely crazy. So I will see you all next time, and I hope you all enjoy this candid video. It's it seems like it's a live stream, but it's not. But I hope you all actually enjoy. It's no scripting, there's no nothing. It's just I'm showing you all exactly what I've been doing. So hope you all enjoy it. I will talk to you all later. Bye.